Hello and welcome to Team 4's Senior Design Project Review. My name is Amanda Berryman and I'm a computer engineer.
My name is Jaime Prince and I'm an electrical engineer.
Hello, my name is Leo Santala and I am a mechanical engineer.
My name is Zachary Fanion and I'm a mechanical engineer.
Hi, my name is Samuel Palermo and I'm a mechanical engineer. This project is aimed to design a 3D printer that is capable of printing two materials in slurry form with adjustable proportionality as specified.
The main design elements of this project consist of a mixing system, an extruding mechanism, Marlin firmware to interface with the control board, and a custom G-code as the control algorithm.
The mixing paddle was designed to disrupt the slurry material as it flows through the mixing chamber to ensure a homogeneous solution. The paddle occupies the majority of the mixing chamber, which allows for rapid ratio change. A ball bearing was placed at the top of the paddle to protect against material flowing toward the driving motor, as well as reduce the torque required by the motor. Next semester, the paddle will be printed of a more durable material and the disruptor design will be optimized to amend the extruded material's consistency.
Our entire housing is tailored to fit the MakerBot Replicator 2X. The housing is composed of a mixing chamber, syringe supports, and a mount for the motor that drives the mixing paddle. Next semester, the housing will be printed in a more durable material. We will also add an access port just above the ball bearing to allow the bearing to be fixed in place.
Our first extruding mechanism design utilizes a rack and pinion transmission to convert the angular motion of the stepper motor to linear motion of the plunger. This design is the cheapest and most lightweight option. The next iteration will feature finer teeth printed in metal to reduce wear and tear as well as improve precision. Next semester, we will improve the design by enabling the user to easily adjust the position of the motor to maintain proper tension between the gear and plunger.
So far, we have made progress in understanding the operation of the control board and code in order to ensure the material proportionality of the printed structure.
As you can see in this video, I am controlling one stepper motor at a time using the Pronterface user interface. By typing in the command M114, I am able to see the status of all the stepper motors and extruders. I am also able to change the tool or extruder so that I can control one of the stepper motors labeled E0 or E1.
During the next semester, our goals are to implement a user interface and be able to print in 3 dimensions.
To our knowledge, there are currently no printers on the market capable of adjusting the proportionality of two materials in slurry form.
This type of technology would be beneficial to the community that is looking to manufacture parts with various material properties within a singular print.